Oral physiology. Introduction. Dr. Akechukwu. What is oral physiology? Oral physiology concerns the functioning and interaction of the teeth, jaws, and associated tissues. It is the study of the way in which the stomatognathous system functions. Loading. Importance to dentistry. Dentistry provides solutions to improve the functioning of teeth and the stomatognathous system. Thus, dentistry aims to improve oral physiology. Mouth. The mouth is one of the main openings of the body. Anatomically, it is bounded anteriorly by the lips and posteriorly by the anterior tonsillar pillars. The roof of the mouth is formed by the hard and soft palates. The floor, by the tongue overlying the sublingual and submandibular salivary glands. The walls are lined by the buccal mucosa. Loading. The mouth is an organ for 1. Ingestion of food and water. 2. Secretion of saliva. 3. Digestion. 4. Mastication, chewing. 5. Swallowing. 6. Taste. 7. Speech and communication. 8. Body defense. 9. Breathing. 10. Thirst. 11. Absorption. 12. Excretion. 13. Judging the temperature and texture of foods. Saliva. Saliva is the watery and usually frothy substance produced in the mouths of humans and most other animals. It is basically the secretion of 3 pairs of glands. Parotid 20%, submandibular 70%, sublingual 5%. Remaining comes from small glands of mouth and pharynx 5%. The basic secretory units of salivary glands are cluster of cells called an acini. These cells secrete a fluid that contains water, electrolytes, mucus and enzymes, all of which flow out of the acinus into collecting duct. The salivary glands are exocrine glands, i.e. glands with ducts, that produce saliva. The glands are enclosed in a capsule of connective tissue and internally divided into lobules, the lumens formed by intercalated ducts which in turn join to form striated ducts. These drain into ducts situated between the lobes of the gland, called interlobar ducts or secretory ducts. All of the human salivary glands terminate in the mouth, where the saliva proceeds to aid in digestion. The saliva that salivary glands release is quickly inactivated in the stomach by the acid that is present there. These glands differ in their acinar aspects of the structure. Parotid gland. It is purely a serous gland. Its secretion is watery and rich in amylase. Submandibular gland. It is a mixed gland and has both serous and mucus secretions. Sublingual gland. Its secretion is mucus and is mucin and glycoprotein. Nerve supply. The secretion of salivary glands is exclusively under nervous control. The gland is supplied by both parasympathetic and sympathetic nerves. Parasympathetic are primarily concerned with the secretion of saliva. When sympathetic nerve fibers are stimulated, it causes vasoconstriction and contraction of myoepithelial cells around the secretory end pieces and intercalated ducts. This contraction forces the saliva into main ducts. Regulation of salivary secretion. On the average, about 1-2 liters of saliva are secreted day. It ranges from a continuous spontaneous basal flow rate of 0.5 milliliters min to a maximum flow rate of about 5 milliliters min in response to a potent stimulus. The continuous, low-level secretion is due to constant low-level stimulation by the parasympathetic nerve endings. Salivary secretion is enhanced by 2 different types of salivary reflexes. 1. Simple or unconditioned reflex. 2. Acquired or conditioned reflex. Simple or unconditioned reflex. It occurs when chemoreceptors and pressure receptors within the oral cavity respond to the presence of food. On activation, these receptors initiate impulses in afferent nerve fibers that carry the information to the salivary center located in the medulla of the brain. The salivary center in turn sends impulses via extrinsic autonomic nerves to the salivary glands to promote salivation. Acquired or conditioned reflex. In this case, salivation occurs without oral stimulation. Just thinking about, smelling, or hearing the preparation of pleasant food initiates salivation through this reflex, also called mouth watering. This reflex is a learned response based on previous experience. Unlike the autonomic nervous system elsewhere in the body, sympathetic and parasympathetic responses in the salivary glands are not antagonistic. Both these increase salivary secretions, but the quantity, characteristic and mechanisms are different. Parasympathetic, it exerts the dominant role in salivary secretion, and produces a prompt and abundant flow of watery saliva that is rich in enzymes. Sympathetic, it produces a much smaller volume of thick saliva that is rich in mucus. That is, the mouth feels drier than usual in stressful conditions. The feeling of nausea, under pathologic conditions, conveys another important stimulus for parasympathetic control of salivary secretion. Nausea strongly stimulates salivation, presumably to protect the oral cavity and esophagus from the injurious effects of vomited gastric acid and other intestinal contents. Parasympathetic input to the salivary glands is mediated by acetylcholine acting at muscarinic receptors. Salivary secretions is the only digestive secretion that is totally under the neural control. Rest of the digestive tract is regulated by both nervous and hormonal control. Composition of saliva. Saliva is composed of 99.5% of water and 0.5% of electrolytes and proteins. Like other exocrine glands, the process of salivation occurs in 2 stages. 1. The glandular portion. The acini produces a primary secretion with an electrolyte composition similar to plasma. 2. The primary secretion flows through the salivary duct. The salivary ducts reabsorb Na and Cl from the saliva and add more K and Cos to it. As a result, the salivary NaCl conc is only 1/7 of that in plasma. 2-stage hypothesis of saliva formation. Most proteins. NaCl resorbed water and electrolytes. Some proteins electrolytes hypotonic final saliva into mouth. Isotonic primary saliva. K+ secreted. Saliva is a mixture of many compounds. The following compound may be found in saliva. However, this list does not include all compounds found in saliva. Water. Lysozyme. Lysozyme is an enzyme found in egg white, tears, and other secretions. It is responsible for breaking down the polysaccharide walls of many kinds of bacteria, and thus it provides some protection against infection. Lactoferrin, an iron-binding protein present in neutrophil granules. By combining with iron, lactoferrin prevents microorganisms from combining with and using iron for their growth and development. Also present in milk, tears, mucus and bile. Lactoperoxidase. Lactoperoxidase catalyzes the oxidation of a number of inorganic and organic substrates by hydrogen peroxide. The oxidized products produced through the action of this enzyme have potent bactericidal activities. Kallikrein. Tissue and plasma kallikrein are peptidases, enzymes that cleave peptide bonds in proteins. It causes the liberation of bradykinin, which is a potent vasodilator. Histidines are human histidine-rich and mostly cationic proteins identified as antimicrobial and fungostatics in human parotid and submandibular sublingual gland secretions. Cystidins, antibacterial viral agents, proline-rich proteins. These protect tooth enamel and bind toxic tannins. Salivary amylase, lingual lipase, RNase, DNase, NaCl, EGA, NaCl, bicarbonate, mucins, lactic acid, choline, ascorbic acid, urea, glucose, cholesterol, blood group substances in some persons, electrolytes, sodium, lower than blood plasma, potassium, higher than plasma, calcium, similar to plasma, magnesium, chloride, lower than plasma, bicarbonate, higher than plasma, phosphate and iodine, usually higher than plasma, but dependent variable according to dietary iodine intake. Mucus. Mucus in saliva mainly consists of mucopolysaccharides and glycoproteins. Enzymes. Major enzymes found in saliva. 1A amylase 2. Lingual lipase. Antibacterial enzymes that kill bacteria. 1 lysozyme 2. Lactoperoxidase 3. Lactoferrin 4. EGA. Functions of saliva. 1. Saliva begins digestion of carbohydrates in the mouth by the action of salivary amylase. This enzyme breaks polysaccharides into maltose. This amylase breaks only A1- 4 linkages and not A1-6 linkages, terminal A1 linkages and branch point A1-4 linkages. The end products are oligosaccharides, maltose and maltotriose. It is inactivated by the acid in the stomach. It has a neutral pH. Salivary glands also secrete salivary lipase to start fat digestion. Lipase plays a large role in fat digestion in newborns as their pancreatic lipase still has some time to develop. Hydrolyzes short medium chain triglycerides. pH is 4-6. It facilitates swallowing by moistening food particles, and by providing lubrication through the presence of mucus. Saliva exerts antibacterial action by means of twofold effect. One by means of lysosomes that destroy certain bacteria, and the second by rinsing away material that may serve as a food source for bacterial. Saliva serves as a solvent for molecules that stimulate the taste buds. Only molecules in the solution can react with taste bud receptor 6. Saliva aids speech by facilitating movements of tongue and lip. 7. It plays an important role in oral hygiene by helping to keep the mouth and teeth clean. It flush away residual food particles, shed epithelial cells and foreign particles. 8. Bicarbonate buffers in the saliva neutralize the acid in food as well as acids produced by the bacteria in the mouth, thereby help preventing dental caries. 9. Saliva helps in the excretion of many substances, e.g. lead, mercury, drugs, alkaloids, antibiotics, viruses. Summary. Oral physiology studies the functions of the mouth and jaws. These functions include secretion of saliva, ingestion of food and water, digestion, mastication, chewing, swallowing, taste, speech and communication, body defense, breathing, thirst, absorption, excretion, judging the temperature and texture of foods. Saliva is the main medium and lubricant that facilitates most of these functions.